Ratios. If I have a ratio of 3 to 17, and I'm asked to write it in two other ways. Well, this is one way to write a ratio. This is another way to write the ratio. Or I can write it like that. If I have a ratio of 4 to 20, I can also write it like this. And I can also write it like this, but when I write it like this, I need to reduce it. Okay. Oh no. Okay. If I tell you that there are 47 marbles in a jar and 20 are green, 7 are blue, 10 are red, and 10 are yellow. So we're going to write ratios of blue to green. So that would be 7 over 20, or 7:20, or how about red to not red? So if there are 10 red, how many are there that aren't red? 37. So we could do not green to the total. So there are 20 green. Well, we're going to do not green to the total. Right, so if there are 20 green, there are 27 that are not green, and then the total is 47, right? Ratios in lowest terms, let's say 16 to 48. So I'm going to do 16 over 48. Okay, we can divide by 8. And I'm going to get 2 over 6. Am I done?
No.
You can divide by 2. All right, if you have decimals in your ratio, are you allowed to have decimals in your ratio? No. So if I have, like, say 3.6 over 4.5. Yeah, by 10, right? And then after that, I'm going to reduce it to put it into my lowest terms, right? And 36 and 45 will both divide by 3, okay. Which will give me 12 over 15, which will divide by giving me 4/5. Unit rate. If I am sewing buttons or something, okay, I can sew 238 buttons in, hold on, no, that's not a good number. That doesn't divide by anything good. Hold on, let me change that to 318 buttons, and I can do that in 3 days. So how many buttons per day? That's a unit rate, right? So I'm going to do 318 buttons, which I'm not going to abbreviate, over 3 days. So for unit rate, I need my denominator to be 1. One day, not days, 1 day. Okay. I can't really. Maybe with a machine. Like I work in a factory and that's all I do all day is put buttons on shirts with a machine. I could probably do that. Okay. Now unit rates can have decimals. So let's say I am traveling and I traveled 2,750 miles in 4 days. And I want to know my per day. Right? How many miles per day? So I'm going to divide both of these by 4. Okay, 4 does not go into 2, but 4 will go into 27 6 times with 3 left over. And then 4 will go into 35 8 times with 3 left over. And then 4 will go into 30 7 times with 2 left over. And it will go into 25 times. So I traveled 687.5 miles per day. I actually did that journey. It's actually 2,876 miles in 3 days. Okay, are they equal or not equal? 2/5 and 16/40. Okay, how do I test it? Cross multiply. And I get 80 and 80. So these two are equal. 3/8 and 24/63. Cross multiply. And that's going to be 189, and that's going to be 192. Not equal, not equal. there is a 5-foot person with a 2.5-foot shadow. And then there is a 75-foot building. How big would its shadow be? So I have person, shadow, building, shadow, right? So corresponding sides, these go together, go in the fraction, and you set it equal to these two in a fraction. So 5 and 75 height goes together. And then 2.5 and x. So shadows go together, and I have small person, large building, small shadow, person, building, person, building. Cross multiply. And I'm going to get 5x is equal to, let's see, 2 times 75 is 150, and then a half of 75, well, half of 70 is 35, and then 2.5. I know that probably didn't make sense, but that was my quick way of doing it in my head. Did that make sense at all, what I just did? I did 2 times 75 is 150, and then I said, and then I need another 0.5, which is a half. So I don't know a half of 75, but I knew a half of 70 was 35, and then a half of 5 was 2.5. So then I added it together. And then I need to divide both sides by 5. So that's 3, 7, 0.5. So a 75-foot building would have a 37.5-foot shadow. We could do a flag pole. Is, how tall are flag poles?
50 feet?
Okay, 50 feet. And it has a shadow of 20 feet. And then there's a person, and we're going to give this a tall person. So we're going to have a 6-foot person. How big is their shadow going to be? That person.
Got no legs.
He's standing sideways. So it doesn't.
But his arms are like that.
Right, he's standing sideways like this.
Okay.
Okay. So corresponding height, height, shadow, shadow. It doesn't show up really well. I mean, it kind of does, but okay. So I typically, for me, I make a rule for myself that I always put the smaller one on top. That way I'd never mess up, because if I do like small, large, and then over here I do large on top of small, it's going to be wrong. You have to have the small one on top of the large one, and small on top of large, or vice versa. But I just, for myself, I made a rule. I always put the small one on top. But you don't have to. This is the same thing. Either of those is okay. I'm going to put that this is what is not okay. This is a big no. You can't have large over small and then small over large. They have to both be small on top or both be large on top. Does that make sense? Okay. So either way, you end up with 50x is equal to 120. Then you'll divide by 50. Which will give you x is equal to 2.4. Because if I do this, 50 goes into 120 twice, that's 100, which leaves me 20, so I put my 0.0, so it goes 4 times. Like, for example, I can drive, let's see, 240 miles on 9 gallons of gas. So how many miles could I go if I had 12 gallons of gas? So you can set up a proportion where you either want miles over gallons for both of your fraction or gallons over miles for both of your fractions. Doesn't matter which. So I'm going to just do miles over gallons because it's in that order. So I don't know how many miles I could go on 12 gallons. I'm going to cross multiply. 9x. Shockingly, I don't have this one memorized. And I did not set that up right. Okay, and then divide both sides by 9. So I could drive 320 miles if I had 12 gallons of gas. Percents.